This is Geometry Unit 8, Lesson 3, Proving Triangles Similar using Side-Side-Side Similarity and Side-Angle-Side Similarity. So we have proved that triangles are similar if we have angle-angle, if we have two angles congruent. We can also prove side-side-side similarity and side-angle-side similarity. That's two other ways of proving triangles are similar. Now, side-side-side similarity is just like side-side-side when you do triangles, except you're proving them similar. Now remember, if three corresponding pairs of sides of two triangles are not congruent, but in proportion, then the triangles are similar. If those triangles are in proportion by the sides, it'll force the angles to automatically be congruent. All right, so what we're going to do is we are going to prove that these two triangles are similar using side-side-side similarity. We want to show that the ratio of all three sides is the same. So we are going to compare the larger triangle to the smaller triangle. We're going to compare the sides. So let's start with the shortest side of the larger triangle. All right, shortest side of the larger triangle would be PQ. So we're comparing PQ would be compared to what's the shortest side of this triangle, would be AB. All right, the ratio of that side would be 9:6. And 9:6 reduces to 3/2. Now, let's compare the middle side. The middle side of PQR would be 12. So that would be QR. Is to the middle side of this triangle, it would be BC, which would be 8. So we are comparing 12 to 8. If you reduce 12 over 8, they divide out to be 3/2. Oh, good so far. And for my third side, my longest sides, I have PR and AC. So PR to AC, if I take 13.5 and divide it by 9, I can even put it in my calculator and see. Whoops. 13.5 divided by 9 is 1.5, math, enter, enter, is 3/2. So you can see that it does come out to be a ratio of 3/2. So triangle ABC is similar to PQR. Notice I said the order correctly. By side-side-side similarity, because all the ratios are the same. These sides are in proportion. So these three sides are in proportion, so the triangles are similar by side-side-side similarity. The third way to prove triangles are similar is side-angle-side similarity. Now notice it's SAS with a tilde. If one pair of corresponding angles of two triangles is congruent, so that's the angle part, and the sides that include those angles are in proportion or have the same ratio, then the triangles are similar. So notice on here, the angle has to be between the two sides that are in proportion, just like you would with side-angle-side congruency. And with this formula, the other two pairs of corresponding angles will be congruent, and the third pair of sides will be in proportion if this is true. So let's show that these triangles are similar. Let's start with the angle. All right, so if we look at angle A and angle S, they correspond. They're in the same place. We have angle A is congruent to angle S. That proves the angle part that we have. So A and S are congruent. Now, the two sides that we need to be in proportion have to be on either side of the angle. All right, so let's take a look at AC and SW. All right, they would correspond on this side of A and S. All right, so let's compare. SW is to AC. All right, the ratio of SW to AC is 16 is to 12. And when we reduce that, that is the ratio of 4:3. Okay, now the other side that would have to have the same ratio, we just did these two sides right here. Because of the angle being here, the other sides that would have the same ratio would be here. So that the angle is between the two sides that you're looking at. So the other pair of sides that we'd have would be ST is to AB. So let's see, ST is 12, AB is 9, 12 over 9 reduces also to 4:3. Okay, so we have proved that the sides are in proportion. They have the same ratio. So the sides have the same ratio, and the angle between them is congruent. So the angle that is between the two proportional sides are incongruent. So that means that triangle ABC is similar to triangle STW by side angle side similarity. Don't forget the little tilde on the end that shows that you're doing similar and not congruent. If it's without that, you're assuming it's congruent. All right, now let's determine if these triangles are similar. Looking at what we have here, all we have is lengths of sides. So what we have to do is determine whether or not these two triangles are similar based on length of sides. Well, that means all three sides would have to be in proportion. All right, so let's start with the shortest side. What is the shortest side of ABC? Well, that would be AB. What is the shortest side of JKL? Well, that would be KL. So we're going to compare those sides. So AB would correspond to LK. All right, so that would be a ratio of AB is 12, LK is 7. So that's a ratio of 12 to 7, or 4 to 7, I'm sorry. Wrote the wrong number down. 4 to 7. Okay, my next biggest side would be BC on this triangle. So let me do that in yellow. Here's BC. What would be my next biggest side in this triangle would be the 21. All right, so that means that BC would correspond to JK. All right, BC is 12, JK is 21. All right, so that reduces, 12 over 21 reduces also to 4 to 7. All right, and then that leaves my third side, my longest sides of the triangles would be JL and AC. All right, so I'm comparing from this triangle, AC is to JL, AC is 20, JL is 35, and lo and behold, this reduces to a ratio of 4/7. So that means these two triangles are similar. All right, name-wise, ABC is similar to, well, let's see, A to B to C. What would A correspond to? Well, it would correspond to L. All right, B would correspond to K, and C would correspond to J. So ABC is similar to triangle LKJ because of side, side, side similarity. These have the same ratio. So all three sides are in proportion, they have the same ratio. So these two triangles are similar by side, side, side. Okay, now for the second pair of triangles, let's look at what we have. We have two sides and we have an angle between them. So let's see if this is side angle side similarity. Well, the angle part is easy. Angle C and angle Z are congruent. So angle C is congruent to angle Z. That gives me a pair of angles that are congruent. Now, the sides on either side of the angle have to be in proportion. So let's compare. Let's use the shorter side right here, BC. Here's BC is the shorter side. What would be the shorter side of the other triangle? Well, it would be YZ right there. So we're comparing BC to YZ. All right, BC is 18, YZ is 24. All right, when you reduce 18 over 24, it becomes 3/4. Okay, now we're going to look at the other ratio of the sides. The other side, the longer side would be 21. Let me do this different color. This side would be 21, and this side would be 28. So we have AC is compared to XZ. So AC is 21, XZ is 28. When you reduce that, that also comes out to be 3/4. So these are the same ratio. So that means triangle ABC is similar to triangle, well, let's see, A corresponds to X, B corresponds to Y, and C corresponds to Z. So triangle ABC is similar to triangle XYZ by side angle side similarity. We proved the angle congruent and the sides on either side would be in proportion. All right, now let's try this in a little different way. Given triangle ABC, D divides CA in the ratio of 3 to 5, and E divides CB in the ratio of 3 to 5. So what's happening here is when we put D and E on this side of the triangle, this piece and this piece would be in the ratio of 3 to 5, and this piece and this piece would also be in the ratio of 3 to 5. So we don't know what multiple of 3 to 5 it's going to be. So I'm going to call this side 3x, and I'm going to call the longer piece 5x, because I don't know what it's going to be. Now over here, again, I don't know what multiple of 3 to 5 it's going to be, so I'm going to call this one 3y, and I'm going to call this one 5y. So that's the information we know right now. Now, we want to prove that triangle DEC, which is the little triangle at the top, is similar to the big triangle ABC. Now, I'm going to draw those out separately so you can see them. All right, so here is DEC. I'm going to label it accordingly, just like we would with a congruence, DEC. And then I'm going to draw the bigger triangle next to it similarly and label it as I want to label it similarly. So if this is DEC, DEC, ABC has to go the same way. A, B, C. DEC, ABC. Okay, now, remember that we have 3 ways of proving triangles are similar. Well, we have side, 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 we have angle, angle, and we have side, angle, side similarity. We don't know anything about the angles except for angle C. What do we know about angle C? Well, isn't angle C the same angle in both triangles? Yep. So we know angle C is congruent to angle C by reflexive. So that gives me a pair of angles that are congruent. This angle right here is congruent. Okay, now, if we have an angle, that's the only angle we have. We can't use angle, angle because we don't know anything else about the triangles. However, we do have stuff about the sides. So why don't we try to see if we can do side angle, side similarity? So we need to get the ratio of the sides correct. So the sides would have to be on either side of the angle. CD would have to compare to CA. So we'd have CD is to CA. This side is to this side. Would have to equal CE is to CB. Okay, now let's look at the values that we have and fill them in. CD we know is 3x, and CE we know is 3y. There's my ratio. Okay, now, what is the length of CA? Remember, CA goes from here to here. So those two pieces together make the whole side CA. So the length of CA is actually going to be 8x. And over here, CB is actually 3y plus 5y, which makes it 8y. Okay, so what is the ratio of CD to CA? This side to the whole side is 3x to 8x. And for CE to CB, it's 3y to 8y. So if I simplify this, the x's cancel. This is in the ratio of 3 to 8, and this is in the ratio of 3 to 8. So that means that these triangles, or these sides, have the same ratio. The sides have the same ratio, and the angle between them is congruent. So that means triangle DEC is similar to triangle ABC by side angle side similarity. It's very important when you have overlapping triangles to draw them out separately so you can see exactly what you have and what you need. So what we just found is that these two triangles are similar because of side angle side similarity. Now, what we've just found, since all the triangles are similar, all the sides are in proportion. And we found that the ratio of similitude back here was 3 to 8, or ratio of similitude. So the ratio of similitude is 3 to 8. So that means all of the sides will be in a ratio of 3 to 8. So if we set up a proportion, 3 is to 8, smaller triangle to larger triangle, DE is 12 and AB is x. 3 is to 8 as 12 is to x. Cross multiply, 3x is equal to 96, and divide by 3, and x is equal to 32. So that means that AB is 32. If you multiply 12 times 3/8, it should get, or 8/3, it should give you 32. So this side will be 32.